Hello, check, check. So, ito yung solutions natin for pre-board 2 ng ating machine design. So, medyo mahirap yung mahirap yung ano ngayon, no, yung machine design last August 2019. So, halos the same lang din naman sila ng ano ng Feb 2020. So, halos puro solving then konting elements. So, try natin. So problem number 1, the engineering stress in a solid tension member was 324 megapascal at failure. So the reduction in area was 80%. So what was the true strain at failure? So ito, naging example ko na to sa ating lecture, no? Sa last lecture natin sa machine shop. So ang formula na gagamitin natin, so may Dane's formula tayo dyan. So ito, so true strain at failure. So percent reduction in area is equals to 1 minus E raised to negative strain, true strain at failure. So yan yung gagamitin nating formula. So percent reduction in area is equals to 1 minus E raised to negative true strain at failure. So yan yung percent reduction in area natin, 80% is equals to 1 minus E raised to negative strain. So makuha natin yung by shift solve, makuha natin yung strain at failure. So ilan yan? So by shift solve, makuha natin dyan 1.61. So the answer is letter A. The next, problem number 2, a hoist with a 170 horsepower engine is capable of lifting a 20,000 pound load height of 20 feet in 10 seconds. So what is the efficiency of this machine? So para itong efficiency, alam natin ang formula ng efficiency is equals to output over input. So power output over power input. So ang output natin kasi dito, so ang output natin dito guys is force times distance divided by time. So syempre ang output natin, kailangan natin ma-lift yung 20,000 pounds at a height of 20 or at a distance of 20 in 10 seconds. So substitute lang to. So efficiency is equals to, so yung force natin 20,000 pounds. Then yung distance 20 feet divided by 10 seconds. So yan yung yan yung output power divided by input power natin na 170 HP. So syempre convert natin itong nasa numerator. So 1 HP per 550 foot to pounds per second. So ma-cancel foot to pounds per second, foot to pounds per second. So ma-cancel rin yung HP. Matitira dito is 42.78%. So yan yung sagot. Letter D. The next, problem number 3. So a slab mirroring operation is being carried out on a 12 inches long, 4 inches wide annealed mild steel block at a feed of 0.01 inches per tooth and depth of cut of 1/4 inches. The cutter is 2 inches in diameter, has 20 straight teeth, rotates at 100 RPM, and is wider than the block to be machined. So calculate the power requirement considering that the workpiece is annealed mild steel with specific energy of 1.1 HP to minute per cubic inch. So, ang power natin dito is equals to specific energy times MRR or yung material removal rate. So, makuha natin material removal rate is equals to width times depth of cut times velocity. So, syempre, kunin muna natin yung velocity. So, velocity pwede natin makuha using feed. So, velocity ng feed to, no? Feed times speed times number of teeth. So, ilan yung feed natin dito? 0.01 inches per tooth. Then, yung RPM natin is 100 revolutions per minute. Then, yung teeth natin dito, so ilan ba yung teeth natin? So, 20 straight teeth. 20 teeth per revolution. So maka-cancel yung revolution, maka-cancel yung torque dito. So inches per minute. So velocity is equal to 20 inches per minute. Then substitute natin dito sa MRR. So width natin is 4 inches. Then depth. So ang depth of cut natin, 1/4 inch. Then ang velocity is 20 inch per minute. So makukuha natin MRR is 20 inches cube per minute. Then substitute natin dito para makuha yung power. So ilan yung specific energy? So 1.1 HP to minute per cubic inches. Times material removal rate na 20 inches cube per minute. So maka-cancel yung inches cube, maka-cancel yung minute. So matitira dito is 22 HP. So the answer is letter B. So ganyan na yung formula dyan. No? So halos ano nato to, yung ladder problem nato to. No? Yung tinatanong dito yung sa ibang problem rin to. No? Tinatanong naman sa ibang problem is yung velocity ng feed at saka yung MRR. So next, problem number 4. A 4 mm fillet weld 50 millimeters long carries a steady load P lying along the weld. If the working stress in shear is taken as 78, calculate the load it can carry. So ang shear stress natin is equals to force over square root ng 2/2 times thickness times length. So substitute lang ilan yung shear stress natin. 78 megapascal. So is equals to force over square root ng 2/2 times thickness. So ang thickness natin dito itong 4 mm. Then times length na 50 mm. So makukuha natin force dito is equals to 11 kilonewton. So the answer is letter B. So yan yung formula ng fillet weld. No? So shear stress ng fillet weld. The next, problem number 5. So a 250 HP motor turns a shaft at 2,400 RPM. The shaft steps down in diameter from 3 to 2.5 inches. Calculate the maximum torsional shear stress if the stress concentration factor is given to be 1.3. So ito naulit lang to sa sa February 2020 board exam. So itong problem na to. So shearing stress ng shaft is equal to 16T over pi d cube. Then syempre, dahil may stress concentration factor natin, ta-times natin yan, times 1.3. So ang diameter na gagamitin natin dito guys, so use smaller diameter. So for maximum shear stress, use smaller diameter. So D is equals to 2.5 inches. So substitute dito. So torque muna. Kunin muna pala natin si torque. So torque is equals, so power is equals to Tn over factor na 63,025. So 250 is equals to torque natin na torque times N natin. So 2,400 RPM divided by 63,025. So makuha natin torque dito is 6,565 inches to pounds. Then ito i-substitute natin dito. So 16 times 6,565 inches to pounds divided by pi times diameter na 2.5 inches raised to 3. So maka-cancel to, magiging PSI na lang, no? Pounds per inches squared. So times 1.3. So lalabas dyan is 19.2. Hindi pala 19.2 guys. So lalabas dito, calculate natin. So 16 times 6,565 over, sa mode 1 nga natin, 16 times 6,565 divided by pi times 2.5 raised to 3 times 1.3. So 2781. So 2781.81. 0.81 PSI. So times, convert natin. So 0.101325 megapascal per 14.7 PSI. So anong sagot na lalabas? Times 0.101325 over 14.7. So 19.2. So 19.2 megapascal. So the answer is letter A. The next, problem number 6. So a steel cylindrical pressure vessel is subjected to a pressure of 3.1 kSI. Its outer diameter is 185 inches and its wall thickness is 8 inches. So what is the maximum principal stress in this vessel? So ano sagot sa number 6? So dito, so syempre stress is equals to PDI over 2 times thickness. So dapat ang gagamitin natin dito is inside diameter. So DO is equals to DI plus 2T. So ilan yung outer diameter natin? 185 is equals to DI plus 2 times 8. So ang DI natin guys is equals to 169 inches. So pag tinesting natin, so thickness divided by DI, so 8 inches divided by 169, ilan yan? So 8 over 169. So 0.047. 0.047. So therefore T over DI is less than 0.10. So 10 volt siya. So tinasting lang natin kung 10 volt, no? So 10 volt nga siya. So gagamit tamang nga yung formula na gagamitin natin. So stress is equal to pressure. So 3.1 KSI times DI natin na 169 inches divided by 2 times thickness na 8 inches. So maka-cancel. Matitira dito is 32.7 KSI. So the answer is letter C. The next, problem number 7. How many kilograms are there in 1 pound? So meron tayong 1 pound times, convert lang natin, 1 kilogram per 2.205 pounds. So maka-cancel is equals to 0.4536 kilogram. So mahilig sa question na ganito yung examiner, no? So pinapalito niya syempre, pag nakita mo 1 pound, then kilogram, may isip mo na kagad 2.205. So maraming nagkamali dyan. So dapat isa-isahin mo. So i-solution mo na lang, no, para mas sigurado. So 1 pound times 1 kilogram per 2.205. So ito dapat sagot letter C. So next, number 8, a beam 2 inches wide and 3 inches deep is subjected to 40,000 ng inches to pounds bending moment at each end. So hinanap dito, value ng bending stress. So para makuha natin yung value ng bending stress, so stress is equals to 6m over bh squared. So 6, so ilan yung moment natin? 40,000 inches to pounds divided by base or yung width natin 2 inches times yung height natin 3 inches squared. So 3 inches squared. So inches cube. So magiging PSI yung kakalabasan dito, no? So, squared. So, PSI. So, ilan to? 13,333.33 PSI. So, times, so 0.101325 megapascal per 14.7 PSI. So, ilan to? 92 megapascal. So, the answer is letter A. The next problem number 9. So, how much will a steel bar be elongated by a load of 15 kips if the bar is 10 feet in length and has a cross-sectional area of 1/2 square inch? Paano to number 9? So, deformation natin is equals to flay, FL over AE. So, ang force natin, 15,000 or 15 kips or 15,000 pounds yan. Then, times length na 10 feet. So, times 12 para maging inches. Divided by area na. So, area is 1/2 square inch. 1/2 square inch. Times E natin. So, ano yung E ng steel? So, ang E ng steel is 30 times 10 raised to 6 pounds per inches squared. So, makakancel yung pounds. So, inches squared. Matitira dito is inches. So, ang sagot. So, ilan sagot dito? So, since ang hinahanap kasi in mm, so naka-mm dapat ang sagot dito eh. So, times 25.4 mm per inch, per 1 inch. So, maka-cancel. Matitira dito is, or ang sagot is 3.04 mm. Letter C. The next, 10. A steel bandsaw blade, 0.032 inch thick. So, find the value of the bending stress when the blade is passing around a pulley of 20 inches diameter. So, may Lane's formula tayo dyan, no? So, stress ng steel bandsaw. So, stress ng bandsaw. So, E times thickness divided by 2R. So, hindi ko napapakita kung paano derive yan, no? So, ilan yung E natin? 30 times 10 raised to 6 pounds per inches squared. Then, yung thickness natin, 0.032 divided by 2 times radius na 20 divided by 2 inches. So, maka-cancel. So, PSI yung lalabas dito. So, 48 or 48,000 PSI. So, equal yan sa 48 KSI. So, 48 KSI. Letter B. The next, 11. What is the outside diameter of a hollow shaft replacing 150 mm diameter solid shaft with equal torsional strength and 50% weight saved? So, dyan may shortcut formula na lang tayo dyan. So, kapag hinahanap yung outside diameter, then, so, itong formula na to, ginagamit lang to kapag sinabing equal torsional strength and 50% weight saved. So, DO is equals to 1 plus square root ng 2 over 2 times diameter ng shaft. So, substitute times diameter ng shaft na 150 mm. So, ang sagot dito is 181.06 mm. So, the closest answer is letter A. The next, problem number 12. So, a power screw is being turned at constant RPM by the application of a steady torque of 300 inch-to-pounds. How much work is being expended per revolution? So, paano tong number 12? So, work ang hinahanap kasi, no? So, work. Paano ba to? At constant RPM. So, since may formula tayo, power is equals to 2 pi Tn. So, 2 pi Tn. Then, hinanap kasi per revolution. So, divide natin ng n. Divide natin ng n. So, ito yung magiging formula. So, power over n is equals to 2 pi times torque natin na 300 inch to pounds. So, convert natin to times 1 foot per 12 inches. So, ang sagot dito is 157.08 foot to pounds. So, the answer is letter C. The next, problem number 13. So, a draft horse walks at the rate of 5 km per hour. What uniform force in Newton must he exert if the output power is exactly 2 kilowatts? So, sa 13, so solution dito, so power is equals to force times velocity. So, ang power natin is 2 kilowatts is equals to force times velocity natin is 5 kilometers per hour. Then convert lang. So 1 hour per 3,600 seconds times 1,000 meters per kilometer. So lalabas dito is in kilonewton. So sagot dito is 1.44 kilonewton. So pag kilowatt, kilonewton lalabas dyan. Then 14, a 10-inch diameter pulley is belt-driven with a net torque of 250. The ratio of tensions in the tight to slack sides of the belt is 4:1. What is the maximum tension ng belt? So sa 14, torque is equals to force 1 minus force 2 times radius. So, ang ratio ng tight slide to slack side is equals to 4. So, 4 is to 1. So, substitute natin. Ilan yung torque? 250. So, 250 foot to pounds times 1 or 12 inches per foot per 1 foot is equals to, so F1 minus, so ito pwede natin gawing F2 is equals to 4, F1 over 4. So F1 over 4, substitute natin dito sa F2 times radius. So ang radius natin is 5, maging 5 inch na lang. No? So 5 inch. So maka-cancel si inches. So F1 is equal to 800 pounds. The next, problem number 15. So if a 650 mm diameter steel flywheel of constant thickness is used, how thick should it be? The specific gravity of steel is 7.85. The inertia of flywheel is 18.31 kilogram to meter squared. So anong gagamitin natin dito? So hinahanap natin yung thickness. So ang formula ng inertia is equals to 1/2 mr squared. So yan yung formula, mass moment ng inertia, Im. So para makuha si mass, so si mass naman, ang formula niya, substitute natin dyan, density times volume, where volume is equals to area times thickness. So kung substitute natin, so inertia is